So here we are gonna see a numerical which is based on beta function, and we will be solving this numerical by using the definition of beta function. So guys, for that here we have the integration from 0 to 1. So 1 minus cube root of x the whole bracket raised to 11 upon 2 dx, and we have to evaluate this integration. So first of all, I'll consider this given integration as I, and then we will solve the given integration. So I is equal to integration 0 to 1 bracket 1 minus cube root of x whole raised to 11 by 2 dx. Now guys, how to get the solution of this, because as we are into beta gamma, how to solve this problem, whether to apply gamma or to apply beta. So I'll tell you the trick to identify the problem from beta and gamma. So guys, you must be knowing the definition of gamma function and beta function. So in the definition of gamma function, we have, here I'll write it for you. So let's say this is definition of gamma function, which is gamma n plus 1 is equal to integration 0 to infinity e raised to minus x x raised to n dx. And the definition of beta function, that is beta m comma n is equal to integration 0 to 1 x raised to m minus 1 1 minus x raised to n minus 1 dx. So now if you will see the definition of gamma function, then in the definition of gamma function we have integration from 0 to infinity, and we should have one exponential term. Whereas in the definition of beta, the limit is from 0 to 1 and both the terms are algebraic terms. Now guys, here if you see our question, then we have all the algebraic terms. So if we do the substitution, that is integration by substitution, then we can create one more algebraic term, and then solving this problem by beta function will become easier. Whereas if you try to solve it by gamma function, then first of all you need to bring this e raised to minus x term over here, and which will be difficult. So hence I'll be solving this problem by using the definition of beta function. Now since this is the definition of beta function, can you observe one thing, that in the second bracket we have 1 minus x, whereas in our question we have 1 minus cube root of x. So first of all I'll remove this cube root of x, and then by doing the substitution for that cube root of x, we will automatically get the first term of beta function. So for that I'll substitute cube root of x as t. So here I'll say put cube root of x, that is x raised to 1 by 3, another form of cube root of x, as t. So here we will get x as, here I'll write x will become, by cubing both sides, as t cube, and dx will be 3t square dt. Now let's see the changes in the limits. So right now limit is from 0 to 1. For x. Now let's check it for t. So when x is 0, this t will give you 0, and when x is 1, you will get 1. So limits for t is from 0 to 1 again. Now let's substitute the values in the integration I. So here we'll get I equal to integration from 0 to 1 minus, now cube root of x we have substituted as t, so here we'll get t bracket raised to 11 by 2, and dx is 3t square dt. So here I'll say t the whole bracket raised to 11 upon 2 into 3t square dt. Now guys, let's solve this integration. So for that I'll take this 3 outside the integration since it is a constant. Then integration from 0 to 1 t square into 1 minus t raised to 11 by 2 dt. Now guys, these two values or this whole integral is matching with the definition of beta function. So see here, in the definition we have x raised to m minus 1 and 1 minus x raised to n minus 1, and in the beta we get m and n. That means this m and n is just 1 greater than the power of x and the power of 1 minus x. So whatever is the power of t over here, I will just add 1 in that. So since here we have 2, inside the beta we'll get 3, and here we have 11 upon 2, so here we will get 11 upon 2 plus 1. So here I'll say it is equal to 3 times beta 3 comma 11 by 2 plus 1. So this will give us 3 times beta 3 as it is, and this will become 13 upon 2. So guys, we can keep it as it is, or if you want you can solve it. So for solution we will be using the relationship between the beta and gamma function. So here I'll show you. The relation is like this: beta m comma n is given by gamma m gamma n by gamma m plus n. So by using this relationship, here we will get it is equal to, here I'll write it is equal to 3 times, this is gamma 3 gamma 13 upon 2 whole divided by gamma 3 plus 13 upon 2, and which will come out to be 19 by 2. Now we'll solve this. So this is equivalent to, here I'll write this 3 as it is, gamma 3, again I'll use one more result, and that is nothing but gamma n is equivalent to n minus 1 factorial. So here we have gamma 3, which is nothing but 2 factorial by this property. Next, gamma 13 by 2. So for that we will use one more result. So you all know that result, which is, here I'll write it is gamma n is equal to n minus 1 gamma n minus 1. So now guys, here we have 13 upon 2 as my n. So by doing this result, or by doing this thing on the right hand side, we will get 13 by 2 minus 1, that is 11 by 2 into gamma 11 by 2. Now for gamma 11 by 2 we will again apply this formula, so that will become 9 by 2 gamma 9 by 2, again 7 by 2 gamma 7 by 2, then 5 by 2 gamma 5 by 2, then 3 by 2 gamma 3 by 2, then 1 by 2 and gamma 1 by 2. Similarly, we'll do it in the denominator for 19 upon 2, so that will be 19 upon 2 minus 1, so that is 17 by 2, then 15 upon 2, then 13 upon 2, then 11 by 2, then 9 by 2, then 7 by 2, 5 by 2, 3 by 2, 1 by 2 and gamma 1 by 2. Now guys, here we can cancel this gamma 1 by 2, and other term, that is 1 by 2, 3 by 2, 5 by 2, 7 by 2, 9 by 2, 11 by 2. So here in the numerator we will get 3 into 2, that is 6. Next 2 into 2 into 2, that is 8. It will go in the numerator, so that will multiply this 6 upon, we will get 17 into 15 into 30. So we just have to calculate this value and calci, and this will be the final result. So here we got the value of integration by using the definition of beta function. So guys, if you like this video and if you want to learn more numericals on engineering mathematics, then do not forget to log into ekeeda.com to get all the mathematical concepts and videos at one place. And you can also follow us on Facebook or Twitter. Thank you very much.